In this video, we will see the derivations of the electric field due to infinite sheet charge. In three different ways, we will try to get the electric field expression. Okay. So, E bar, that means electric field intensity due to infinite sheet charge. So, the charge is available in the form of the sheet of infinite dimensions. We'll assume that that sheet is available on the xy plane. So here, even though I am taking certain boundaries here, actually it is unbounded because of infinite dimensions. So on the xy plane, I have oriented this particular infinite sheet. Okay, so this is our infinite sheet. So due to this particular infinite sheet, we need to get the electric field intensity at some distance, and we will assume the at one point on the z-axis we are going to get electric field intensity due to this one. So this is the point where the coordinates are given by 0, 5, z. On z-axis, the coordinates in cylindrical coordinate system are given by 0, 5, z. Okay. Why? In the sense, I am assuming that the point on the xy plane is rho, 5, z. So with respect to this one, the point on the z-axis is given by 0, 5, z. On the xy plane means z coordinate is 0, so here I am taking it is 0. Okay, so first what we are doing in the sense, instead of considering the entire infinite sheet, we will take one point on the sheet. Okay, so at that particular point, the coordinates are given by rho, 5, 0. So due to this differential element, we can consider this is the differential element. Due to this one, how much amount of electric field is there at this particular point on the z-axis? That is what we have to calculate. Then we will integrate that electric field to get the overall response, to get the overall electric field due to the entire infinite sheet. That is the procedure we are following. So this one we are taking R bar. So due to the infinite differential element, what is the electric field? Differential electric field you will get due to the differential charge dq by 4 pi epsilon magnitude of r cube into r bar. This is written from the Coulomb's law. Okay, so dq means how to write here, because we are working with the sheet charge, it is having sheet charge density rho s coulombs per meter square. Okay, but I need coulombs only. Dq means here coulombs. That means dq is actually given by rho s into ds. If you multiply coulombs per meter square with area meter square, you will get coulombs only. Differential charge you can able to get. That is what we have to write. But here rho s is uniform, we will consider like that. Next, rho s, sorry, ds. So this infinite sheet, that means it is a area element. Area element is nothing but ds is given in the cylindrical coordinate system with the changes in the rho, with the changes in phi. But when you take the changes in phi, what is that differential length? You will get rho d phi. Not only d phi, you will get a rho d phi. That rho I am writing here, d phi I am writing here. Or for your convenience, d rho is one differential length, rho d phi is another differential length. If you multiply these two, you will get differential area. That is what I have written here. So dq is equal to this expression we have to use. So dq means rho s, rho d rho d phi and r bar. R bar is observation point minus source point. Observation point is on z-axis where we are calculating electric field. and source point is the point where the differential element is available, that is rho comma 5 comma 0. So observation minus source, if you perform 0 minus rho is rho minus rho cap. 5 minus 5 is 0 plus z minus 0 is z cap. So this is nothing but our r bar. So that is what I am substituting here, minus rho cap plus z cap by 4 pi epsilon magnitude of r cube is there. Magnitude of r is nothing but rho square plus z square whole power 1 by 2, but cube is there, that's why 3 by 2. This is the differential electric field due to the differential element available at rho phi theta, sorry, rho phi 0. Okay, then same kind of differential element may be possible here also. So due to this one, if the electric field direction is in this way, due to this another differential charge element, electric field will be like this. That means the resultant electric field, if you observe, the resultant of these two vectors will be in a different manner will get, that is along the z-axis only. That means you will not having rho component in the resultant electric field due to the entire sheet, due to the entire infinite sheet. If you consider only this particular electric field, that means due to the differential element available at rho phi 0, you will be having rho component and z component. But when you consider the entire sheet, okay, all these things, the rho components will be cancelled and you will get only z component. So that in the next step itself I am writing that one. So I can take dE bar is equal to rho s rho d rho d phi. I am eliminating that rho component, I am writing only z component by 4 pi epsilon rho square z square whole power 3 by 2. Now variable is this particular rho and phi. We have to do the integration, remaining all are constants. So accordingly I am writing the equation. Rho s is constant, rho is variable, phi is variable, but z is constant. Z cap I am writing here by 4 pi epsilon. Next, whatever the variables are there, all those variables I am writing here, rho d phi, and here rho square plus z square whole power 3 by 2. This is what we have. Next, d phi is also there. So for this we have to do the integration. Okay, so E bar is equal to rho s z cap by 4 pi epsilon integral. Rho is actually changing from 0 to infinity. Rho will not take negative because rho is the radius, so we have to take 0 to infinity. So rho d rho by rho square plus z square whole power 3 by 2 integral phi changes from 0 to 2 pi. Phi ranges from 0 to 2 pi and d phi. Okay, so it is equal to rho s z cap by 4 pi epsilon. Now in order to do the integration of this part, I am taking here within the note, I am performing the integration. That one is rho square plus z square is equal to t square. Will consider if you perform the differentiation here, z is fixed, so you will be having 2 rho d rho is equal to 2t dt, and limits also accordingly you can able to take. So if you take rho is equal to 0, t is equal to z, you will get. If you take rho is equal to infinity, t is equal to infinity, you will get. And numerator is rho d rho means t dt by, it is t square actually. Rho square plus z square means t square, but power 3 by 2 is there, so you will get a t cube. It is overall 1 by t square. For 1 by t square, for 1 by t square, what is the integration? minus 1 by t. Okay, limits are z to infinity, so it is equal to minus 1 by z is, sorry, 1 by infinity is 0 minus 1 by z. That means you are getting 1 by z is the integration of this part. Okay. This part is having 1 by z is the integration, and integration of 1 with respect to 5 is 5. If you substitute the limits, you will get 2. Okay, so what did you get now? Z will be cancelled, pi will be cancelled, 2 1s are 2 2s are. That means you are getting rho s by 2 epsilon z cap. This is an electric field due to infinite sheet charge. But what is to be remembered here? What is the importance of this one? What is the specialty of this particular electric field due to the infinite sheet means it does not depend upon the distance, okay, of the observation point from the sheet. If you observe, what is the distance we have taken from the sheet to the observation point? Here observation point is there where we have calculated this electric field, that is around z distance is there from the sheet. But if you see the electric field expression, rho s is fixed, uniform, we have taken charge density, 2 is constant, epsilon is also constant, okay, and z cap. So this everything is constant only. Constant by constant means you will get the constant electric field you will get. With respect to distance, the electric field is not decreasing here. But in case of the point charge or in case of the line charge, you can able to understand that with respect to distance, as you are increasing the distance, the electric field intensity is reducing. But in this case, it is maintaining fixed value. Okay. Now we will do this electric field intensity derivation using line charge due to infinite sheet charge only. But we are going to get that expression rho s by 2 epsilon using different manner. Okay, electric field due to infinite sheet charge using Royal concept, line charge density concept. Okay, so understand this one very carefully. So here I am taking one sheet. Now I am taking this x-axis, y-axis, z-axis. Sheet is on yz plane now. You can take anything. Just I am changing. In the previous case we have taken sheet is there on the xy plane and observation point is there on the z-axis. Now sheet is on yz plane and observation point, that means where we are finding the electric field, is on x-axis. So observation point is given by x comma 0 comma 0. So now in the previous case what we have taken, what is the approach we have followed in the previous case means xy plane we have taken, we reduced the x variable differential x element we have taken, or dx we have taken simply, differential y element we have taken dy. So we reduced x dimension, we reduced y dimension, so that we got the differential point. That is what we have represented with rho comma 5 comma 0, one single point. But in this particular derivation, what we will do in the sense, we will not reduce, okay, we will not reduce this z component. Z will be of infinite length only, but we will reduce y variable. Okay, so what we will do in the sense, it is 0 origin. From this on the right side I am traveling means y value is increasing. So one differential element we will take which is of y dash distance from the origin. It is of infinite length in the z direction. It is of infinite length in the z direction, but it is maintaining very small distance or infinitesimally small in the y direction. So it will become now infinite line. you can see one sheet can be created because of the many lines like this. Okay, so out of all these lines, so what I am doing is I am taking one single line, that is nothing but this one. Okay, and this is of infinite length. Okay, because in this direction we are taking z is infinity. In this direction z is minus infinity. So it is an infinite line. It is infinite line charge. So what I will do in the sense, due to this infinite line charge, what is the electric field I have to calculate? Then I will integrate this electric field by having or by changing this z from minus infinity to plus infinity. That is what I am going to do now. So anyhow, it is having y distance from minus infinity to plus infinity y variable. And upon this one, if you integrate in such a way that z is changing from minus infinity to plus infinity means y changes, z changes, so the sheet can be created. This is the approach we are following to get the electric field due to infinite sheet charge using line charge density electric field. Okay, so once again I'm drawing the, this is a observation point where the coordinates are given by x comma 0 comma 0, and this is the differential point we are taking on the line where the coordinates are given by 0 comma y dash comma 0, and this is the perpendicular distance from the sheet or from the particular line to the observation point r bar. So r bar is equal to observation point minus source point, that is x minus 0 is x, 0 comma y dash, that is minus y dash comma 0. Okay, so now we know electric field due to line charge is equal to rho L by 2 pi rho epsilon a rho cap. Rho L is the line charge density, 2 pi is fixed value, epsilon is the permittivity, that is also fixed value, but rho is the perpendicular distance from the line charge to the observation point, and a rho cap is a unit vector in the direction of rho increases. Okay, so like this we have to take, but we are working with sheet charge which is having the surface charge density rho s, but we need now the line charge density rho l. So rho l is given by rho s into some element we have to take here. Rho l is nothing but coulombs per meter, rho s is nothing but coulombs per meter square. That means here with distance vector we have to multiply. Okay, what is that one? Dy dash, because we reduced y dimension up to 0, infinitesimally small, that means dy dash. If you make y up to infinity, then it will become rho s only, sheet charge, it will become the sheet charge. So that is what we have to consider here. Okay, now we'll continue to do this one. So differential electric field is equal to rho s dy cap. This is what I have written instead of the rho l by 2 pi. What is the perpendicular distance here? First I am writing epsilon. Perpendicular distance is square root of x square plus y dash square. Okay, and arrow cap is nothing but rho by magnitude of rho. Rho is nothing but what? X cap minus y cap, by again we'll get this one, that is square root of x square plus y dash, it is actually y dash square. So it is equal to, you can see, rho s dy cap xx cap minus y dash y cap by 2 pi epsilon, it is x square plus y dash square. Okay, and again same thing, if it is coming towards the, because of one line, because of this line on the x-axis, if you get the electric field in this direction, because of another line which is available this side, you will get electric field this direction. That means the resultant electric field is in the x direction. So there is no need to take this y component. So what we can write, rho s into dy dash into xx cap by 2 pi epsilon x square plus y dash square. So now rho s xx cap by 2 pi epsilon, and here integral y changes from minus infinity to plus infinity, dy dash by x square plus y dash square we have to perform. So what we'll get? So total electric field is equal to, here we have x changes, sorry, y changes from minus infinity to plus infinity, dy cap by x square plus y dash square is there, and here rho s into xx cap by 4 pi, sorry, 2 pi epsilon is there. Okay, now rho s into xx cap by 2 pi epsilon, it can be, because of it is a even function, we can take 2 times of y changes from 0 to infinity, dy dash by x square plus y dash square. So it is equal to rho s into xx cap by 2 will be cancelled, so you will get here pi epsilon, and it is the integral of this particular form is given by 1 by x into tan inverse of y dash by x. Like this we can take, where the limits are 0 to infinity. So here xx will be cancelled, so rho s into x cap by pi epsilon, and if you substitute the limits, the tan inverse of infinity means pi by 2, so you will get again the same expression rho s by 2 epsilon x cap, but approach is different here. But in the first case we got here rho s by 2 epsilon z cap. In the second case we got rho s by 2 epsilon x cap. Both are same. Why? In the first case we have taken sheet is on the xy plane. In the second case we have taken sheet is on the yz plane. So in both cases you can able to observe electric field is perpendicular to the plane xy plane, perpendicular to the plane yz plane. So that in general we can take a n cap. Direction is a n cap means a normal to the sheet. So in this way we can able to do the derivation in a second way, that is using the line charge density also. Now another approach we'll see for the calculation of the electric field. Electric field due to infinite sheet charge using circular disc. Okay, here what is the approach means, when you take a rectangular sheet in case of the first case, for example it is in the x direction, it is in the y direction. If you make x is extending up to infinite, if you take y is also extending up to infinite, it will become infinite sheet. In a similar manner, if you take a circular disc, it is not a circular ring, circular disc having the charge density rho s. Circular ring means nothing is there inside and outside. So charge is situated in the form of a circle. This is called circular ring. So it is a closed line. So it is having the line charge density rho. But when you take the circular disc, the charge is accumulated in the form of the circular disc like the circle. The charge is available in the form of the circle. There is a difference between circular ring and circular sheet. Okay, so like this, this particular sheet is available, and it is having the surface charge density rho s, or sheet charge density rho s. Now we have taken this one. So For this particular sheet, if the radius is r, and if you can able to make this r is tending to infinity, then this circular disc will become infinite sheet. Okay, so first we will find the electric field due to this finite radius circular disc. Then we will make r is tending to infinity, we will get electric field due to infinite sheet. This is the approach we are following. And the steps are similar to whatever the first derivation we have done using this rectangular sheet. In a similar manner here it will be available. Okay, so now we will take related diagram here. So we are placing this circular disc of finite radius r, okay, on the xy plane, and we need to find the electric field due to the circular disc on the point where it is available on the z axis. So that is 0 comma 5 comma z. And the point on the disc that is on the xy plane, that is given by rho comma 5 comma 0, and this is the r bar. Again same procedure. If you take electric field due to this point, that is in this direction, another point in this direction, resultant electric field is in the z direction. That is what we have to take. Okay, so r bar, same approach. R bar is equal to observation minus source, so minus rho cap plus z cap. So from the Coulomb's law, electric field due to infinitesimal small differential element is given by dq by 4 pi epsilon magnitude of r cube r bar. Okay, and because it is a sheet only, having the charge density rho s, we can take here dq is equal to rho s into changes in rho d rho, changes in phi rho d phi. I am taking this is everything is related to dq by 4 pi epsilon magnitude of r is minus rho cap plus z cap by rho square plus z square whole power 3 by 2. So it is equal to, so in the resultant electric field we will be having only z component, so we have to remove this rho component. So here I am writing d bar is equal to rho s rho d rho d phi z cap by 4 pi epsilon rho square plus z square whole power 3 by 2. It is equal to rho s is uniform, so constant, and by 4 pi epsilon is constant, z is constant, z dash we can take like this. Now if you take rho changes from 0 to infinity, that is directly infinite sheet. But now what we are doing, this is circular ring disc can be created by changing rho value from 0 to r. So rho limits are from 0 to r. That is what we have to remember. Okay, and phi is anyway changing from 0 to 2 pi. So if you take integration for d phi, you will get 2 pi. This part is over, phi part is over. Now we need to do the integration. E bar rho is equal to 0 to r, we have to perform, that is rho d rho by rho square plus z square whole power 3 by 2. Okay, so this part separately I am doing here within the note point. See carefully. Again same approach what we have done in the first case. Rho square plus z square is equal to t square. So rho d rho is nothing but t dt. So integral t t is equal, if you substitute rho is equal to 0, t is equal to z, you will get, if you substitute rho is equal to capital R, what is the t? R square plus z square under root we will get. This is the t value, t limits. Okay. Next, rho d rho means t dt we will get by t power 3. That means 1 by t square. So minus 1 by t is the integration. So if you substitute the upper limit, you will get r square plus z square, here 1 by z. This is the integration part. Now the total electric field, if you want to write rho s z z dash by 4 pi epsilon into 2 pi. Now I can write, sorry, here it is minus lower limit we have to substitute. If you multiply this minus inside, 1 by z minus 1 by square root of r square plus z square. Okay, anyway this 2 pi, this 4 pi can be cancelled and resulting 2. This is what we have got the electric field for the circular disc of radius capital R. This expression you can able to use for the circular disc. Now from this, how to get infinite sheet charge means, as I said in the beginning, you have to take R is tending to infinity. When you make R is tending to infinity, this particular portion will go to 0 because 1 by infinity it will become 0. So 1 by z minus 0 is 1 by z. This z can be cancelled with this z. What is the remaining thing? We got E bar is equal to rho s by 2 epsilon z cap only. So same expression we got. Same expression we got by replacing z with r with infinity. Okay, so in this particular way we can able to derive the electric field intensity in 3 ways. So the summary I will give here. The overall concept is about getting the electric field due to infinite sheet charge. So what did we get? E bar is equal to rho s by 2 epsilon a n cap. So if your sheet is there on the xy plane, and if you want to get the electric field above the sheet, that means here z axis is there. So the electric field direction is given by a z cap. For example, if your observation point is below the xy plane, again the electric field is perpendicular to the sheet only, but here you will be ended with the minus a z cap. For example, your sheet is there on the xyz plane. This is y, this is z. Now this is x. You need to calculate above, that means towards the positive x direction. If you want to calculate the electric field, then E bar is given by rho s by 2 epsilon x cap. If you want to calculate the electric field towards the negative x direction, then you are going to get a minus x cap. Like this you will get a x cap or minus x cap, whatever. So what did you understand here? Anyway, electric field is perpendicular to the sheet, and based upon the orientation of the sheet, the perpendicular direction will be changed. So that in general we will give here a n cap, normal to the sheet. Okay, and in the first approach we have taken rectangular sheet to infinite sheet. For this we have made x is tending to infinity, y is tending to infinity, or rho is tending to infinity. This is what we have taken, and phi changes from 0 to 2. In the second case, we have taken sheet is the collection of so many lines. So one line is having rho L, and rho S we have got with rho L by making y is tending to 0. So like this we have taken. In third approach, circular disc we have taken of radius r, and by making r is tending to infinity, we are getting again the infinite sheet. Okay, so we have got the derivation of the electric field intensity due to infinite charge in three different ways. Okay, thank you.